Welcome everybody to our talk in which we are trying to convince you that microservices and platform as a service are not only a true story but also a true love story. Let me first start with giving a bit of context of what we are going to present you. So the platform as a service offering that we are going to show you is hosted in the G-Cloud. So first question is, what the hell is this G-Cloud? So G-Cloud is an initiative of the Belgian government where we have a complete program of creating synergies in this government IT. And the idea is that we have to deliver some benefits, and by increasing the collaboration we want to increase also the efficiency and the quality of the services that we deliver as a government IT, and very important since we are all taxpayers, at a lower cost. So to do that we have to have a lot of capabilities that we can influence in this large program. So we are going to attack procurement, that we can buy things together, leverage our power with the vendors. We are going to do projects together. We are creating services that can be reused, and especially we are going to share the knowledge and the expertise that exists in all the government agencies. So this cloud is a very broad program. There are a lot of different entry points to allow everybody to fit in nicely. So you can start with housing as a service and move up to the more cloud-like services that we are going to present you today, like the platform as a service offering. The main idea of these different entry points is that you can come in where you need, but it is clear that if you want to have all the benefits of a cloud, you have to be more to the right, because the main idea of this cloud is to reduce the customer operational complexity by handing over that complexity to the cloud, and that way you will be able to get these benefits. So I'm from Smals, and we are working in this program as a service provider. We are the service provider for some services already in production with virtual machines, and also for this platform as a service that we are going to present you today. A platform as a service offering that is created also on open source products. So we have OpenStack, we have OpenShift, which is the real platform as a service core, and around that there are a lot of other projects that are needed to get this service up and running. And we are not only using the open source community material, but also the G-Cloud itself is a community cloud where we are participating together and having that community vision from the beginning. So how do these different entry points translate to more practical things? Like I said, you can start really low end by just sharing the housing in the data centers, and there you are coming with your complete rack, but you keep all the possibilities and all the administration at your side. And then you can go to bare metal as a service where you just rent the physical hardware. You can get a hypervisor, and then we start becoming more cloud aware, where we say, oh, I don't need to have access to the hypervisor, I just need a virtual machine. And then we can start mixing those virtual machines on the same infrastructure and start getting these benefits. And one step further is even saying, okay, the virtual machine is too large for me, I want to have a more fine-grained control, and we are going to talk about containers, I'm afraid. So what we see is in these different entry points is that the more you are to the left, the more you still think in terms like, okay, I have this kind of server, and that is my vendor, and this is my solution. But if you want to reduce that complexity, we have to become more agnostic of that. We have to see this just as a compute resource that is scalable and that is elastic. So both worlds are there. It's clear that by putting this into production, we can't replace everything that's there. We will need both worlds and align them. So if we look in more detail specifically to the platform as a service, it is already used. This is a graphical overview of the different containers that are running in the various stages of the software lifecycle. You can see them color-coded. As you can see, there's still every large circle is an institution, a member institution that is working on it. The smaller circles define the logical groups. So you see there's a lot of testing going on different levels, but there is already some green there are real-world applications that are alive. And especially if you see it visually, on the lower left side, there is this one circle who is really well represented in all different stages, and that is CAAMI-HZIV. So we thought it would be a good idea to let them explain why they were opting for our platform as a service offering. So, Gilles.
Okay, hello everybody. So I'm from CAAMI-HZIV. I'm first going to introduce a little bit this institution. So CAAMI-HZIV is a federal mutual insurance. So it's one of the Belgian mutual insurance, okay, but it's the federal one. So it's an institution of social security whose goal is typically to help people who receive healthcare services, people who get ill, to get reimbursed, to get paid back. It's not the biggest mutual insurance, so it's a rather small one. It has 80,000 members in Belgium, and 15 regional offices a little bit everywhere in Belgium. Okay. Internally, at CAAMI-HZIV, we have 250 users, 250 agents using our ICT applications. And in 2014, CAAMI-HZIV started a big modernization program. So there were lots of legacy stuff, legacy applications, which tend to give us problems. So we started to modernize that. The first project we started with is the healthcare reimbursement project. So I'll just try to explain it do a really small summary. So our members here, they need healthcare services. Maybe they have medical problems, so they go to the doctor or in a hospital. Okay, they receive those healthcare services, and eventually they get a green paper, a doctor consultation certificate, which tells who gave what service to which member, which person, and how much they had to pay for. Okay. Whenever this is done, the certificate is given to CAAMI-HZIV, and internally people have to compute the amount of money we want to pay back to the people. It might seem kind of simple, but it's not as simple as that. There are lots of parameters. Whenever the amount is computed, of course, it is paid back to our members. When we started modernizing, we chose a microservices architecture. Instead of explaining you our, let's say, interpretation of microservice architecture of whatever, let's say, Go theory, I will just list, let's say, a bunch of problems we had at that time that made us choose microservices. So first off, we had 3 or 4 big monoliths, okay? We were organized monolithically around them with team dedicated to each layer, okay? They would grow large and large, okay? One of them, for example, weighs 600,000 lines of code, and this typically wouldn't give us much productivity. We started to have problems with that. We started to have problems to migrate to make it evolve, okay? In those monoliths, reuse was done through homemade frameworking that was used by each of the monoliths, and access to the same database, okay, data integration. And so with the time, it started to be a problem. People had to maintain the framework. It was really touchy. If you touch it, you could break it all, okay? And on the end, one of the consequences of that is that we started to have really aging technology. We're starting to have really old databases, really old runtimes that were not supported anymore, and that we couldn't even deploy on virtual machines because they were too old. It was not possible, that sort of stuff. On the other side, for organizational stuff, the deployment, the configuration, which was completely manual, tended to give, let's say, really horrible weekends of deployment nightmare, where you just try to fix it in production and so on. So all those stuff we didn't want anymore. So we searched for an architecture that would give us solutions to that, and we chose microservices. Another, let's say, other facts that typically pointed us to that architecture is that our project there can be kind of complex. Okay, there are lots of parameters, as I said. So typical numbers, there can be 50,000 type of healthcare services. There are 50 type of healthcare provider. Each of them has a list of qualification. There are an infinity of family composition differences. And so this all together gives you, makes that, in fact, it's difficult to say how many money you have to pay back to somebody that went to the doctor. So basically, we ended up with 5,000 business rules, which tend to be regularly modified. Okay, they depend on laws. So every month we have to modify them. We have deadlines and so on. So we needed something really flexible. Okay, so that's one, let's say, big fact. The second one is that in the diagram I showed, you saw healthcare providers there on the right. You saw members. Okay, and typically other projects, other processes that exist in CAAMI-HZIV use the same concept, more or less, a bit changed, okay? So this typically give us, we thought, okay, we need to do something that will enable reuse, lots of reuse for the next years, for the next projects. Okay, then we started developing the system, okay? We started creating services, and we ended up thinking, okay, we have 1, 5, 10 services now, where are we going to put them? The thing is that before we just had one monolith in a virtual machine, okay, but it was not really feasible for us to have one microservice per virtual machine, as on the end, we thought maybe we'd have 50 services, okay, we'd have 50 virtual machines per environment. Okay, it was complex and not really adequate for us. So we started looking at containers. Docker, typically, okay, we got a Docker, we installed it and tried to play with, set up our development environment in it, and it was easy, it was friendly, it was nice and flexible. But it was one node, okay, one node Docker. And typically we thought, okay, that's not possible for production. We need more, we need something a bit resilient, we need a cluster. And there were lots of cluster solutions, okay, including Kubernetes, Flocker, or whatever, but they all shared the same characteristic. They were kind of complex, okay, and maybe we thought, okay, we'll need an expert, maybe we'll need a full-time expert to maintain that. It's not easy. So we started searching for an out-of-the-box solution, and then that's where we started collaborating with the G-Cloud.
Yeah, because we in the G-Cloud had already this offering based on Red Hat OpenShift. For those who who aren't familiar with the solution, I have here a quick diagram. So in the middle, the red sections are the actual compute nodes. So that's what Gilles was talking about, just Docker host where you are running your containers. Clearly, as indicated here, the platform doesn't care on what you put into the container. You can mix whatever technologies together. But OpenShift creates a complete layer around that. So first of all, it makes sure you can run your nodes on whatever kind of infrastructure. It will help you in handling the persistent storage that you want to inject in your stateless containers that are running somewhere in this cluster. It handles registry and all kinds of things. It has a routing layer that exposes things to the outside world. And most importantly, everything is handled by masters. These masters are the only entry point that is used by both your developers and your operational team. So that is hiding the complete complexity of the cluster that is behind it. So this setup, we are going to show you some real-world demos with that. We didn't bring our complete G-Cloud, but on that little machine we have in a virtual machine a complete OpenShift installation, which we hope is still running. But after the demos of this morning, yeah, you know what to expect.
Okay, so we've seen that nice schema, we've seen that nice platform, okay, with lots of complexity, lots of squares with colors and so on. But now the question is, how can we take a Docker image and then just put it in it? So how does it work? Do we need Docker Compose? Do we need whatever, deployment config routes, something a bit strange? Can you explain that to us, Jef?
Yeah, so the way it works in OpenShift is really that this platform is resource-driven. So you are presenting your requirements via the resources you need to the platform, and then it will decide where to place it in the cluster. So if you would have looked at the diagram in a lot of detail, you would have seen that it's not containers that are listed there, but pods. And what is a pod? Well, it's simply a group of containers. So the simplest pod is just a single container. but you can do more sensible things with it and combine them for you. The resource with which you are defining how to create that pod is via the deployment config. The deployment config will tell the platform which image to launch, in how many instances you want it to do, the way you want to deploy that, if you need persistent storage, yes or no, and how to inject that. And all these resources are file-based. And the system both supports YAML or JSON. It's equal, whatever you like. You will see that in the examples. The interaction, as we said, you can interact always with those masters. They have an API. You can attack that directly. Clearly, they have a web console. So in the web console, you will see a resource-based view. You see here, you see the pod, you see on which image that is based. But they also have a very powerful CLI. So the CLI, it's easy to use for the developers, but it's also a very easy way to script things. That or the API. So,
okay, it's time for a little demo.
Yeah.
So, first thing I'm going to show you is no, not that. Is a case study application I made. Okay, so it's, let's say, based on the example I gave, the healthcare reimbursement business. So here I made a small healthcare provider REST API, okay, which will basically return a list of healthcare providers, okay. We have two types. We have some hospitals, and we have one doctor, okay. So this basically is a really small Spring Boot application. We typically use Spring Boot in our microservices architecture, but it's a bit specific, it's a bit cleaner so for the demo. Okay, so now I have that. Typically, I should build a Docker image. I won't show you in the demo how that works, but it's already done. Okay, I have a Docker file here, which is not so important, but that transform that to a Docker image. And then I have my YAML file here that contains the resources from my healthcare provider service. So basically here we have a deployment config that tells which pod we have, okay, and how to deploy it. So this is the Docker image here that will be used, okay. Then we use a service, okay, which is a network abstraction, okay, that will expose our pods so they can be called, okay. And this is a route there, okay, which will allow me to query the pod using my browser, typically. Yeah? Okay, I'm going to take that, okay, and copy-paste that into my own OpenShift here. Okay, so I'm logged in. I have, okay, a dummy project, OpenShift project that's there, and I'm going to add the YAML file I just showed you. Okay, let's create it. That's done. Okay. So here we see the resources. It's starting. All those nice colors there. It's starting. It's blue. So it's okay. So I can click on the route and see, oh, 503. Okay. In fact, it's normal. We'll see why just a little bit later. So now I refreshed it and I have my healthcare provider service, which is running there. If we look a little bit more, so we have here the route. I clicked on it. We saw it. We have here the service, okay, which is basically a virtual IP, okay, which typically points to my pods. And then I have my pods there. They come back here. And we can see, okay, the image. We can typically see maybe stuff like the logs of the application that has started, okay. So this small demo show you a bit how to run one microservice in an OpenShift. So in production right now, since April, we have we use that kind of solution. This is a screenshot of our production environment. We have, I think, 35 deployment configs running with something like 60 pods and lots of services and routes. Okay, but I only show you how to just put one pod in one project. This will typically not be sufficient, of course. Okay, so we need a little bit more mechanism. So the next challenge, the next question I'm going to ask is, what if I want multiple times the same application to, let's say, isolate them, to have environment. Well, how can I model environment? So basically, what we'll want on the end is to be able to create a pipeline where, going from our source code, we can go up to production with different test phases, okay? Using the same binary, but maybe a bit different configurations, okay? In the pipeline here, we start from test environment, we go to quality assurance, and then production. It's a rather short one, okay? But typically, you might have different requirements for the different environments. So, Jef, can you show us what to do here?
Yeah, so the first interesting point that you raised is how to isolate your application in this environment. So in the demo, we already saw one project, and in OpenShift, you can create as many projects as you want, and that you can use very easily to model environments. So here we have a setup where we say, okay, we have a production environment, a QA environment, and a test environment. 3 different projects to put in the end, our Docker container. First of all, each project has its own user management. So for each project, you can decide who can act on it. You can apply your own governance. Let's say you have an operational team and a dev team. Everything is up to you. And you define that role-based with role-based access control. Secondly, for the isolation, each environment automatically is created in its own isolated network zone. So that means that if you don't do anything special, the containers can't mix between the environments, which is really nice because you don't want to link your test container to your production database, to give just that example. Also related to every project is a number of quota, where you can say, okay, these are the number of resources that I am giving for this environment, just to make sure that if your production environment needs additional resources, that the guy who is creating 55 test containers isn't stealing the resources you need later on. And these resources that you are giving are both the amount of memory that you can give to your containers and the amount of CPU. So what the platform is doing is taking all this metadata and applying that into Docker commands. In the end, it's still Docker that is providing the isolation and who is doing the real work. It's just the platform who is handling the orchestration for you. Your second question was, okay, now I have these nicely isolated environments, but I only have one image. How do I make it behave like the production version? And the first way of doing that is simply using environment variables. That is supported by every solution. It is easy, it is well known, and you can specify them in this deployment config. Then you can list them all. You can also change them individually via the CLI or via the web console as you like. In the browser, they're all listed, so it's really nice, it's really clear. The only problem is, yeah, that is working for text, but I also have these key stores and certificates and things like that are specific for my environment. So their environment variables, it's a bit of a nuisance. So there we can use a second offering, which is called secrets. And a secret is a way of the platform of injecting binary data as a file on the fly into your Docker container. So it's using the volume mechanism that is offered by Docker to inject that on the fly. But the platform adds a complete security element on top of that. You can decide who can see your secrets. You can give access to certain people to have access to certain things of the container, but not the secrets. So that way you can really keep those things very, very much protected. And since the platform is orchestrating that over the containers, if you have, for example, this key store example, and that key store is used in multiple services, you only have to create a secret once, and you reference it in all your different pods, which makes it really easy to update that secret if your certificate expires. Also, one of the things that the platform offers are templates. So templates is what you expect of it, a way to describe how to create this application. You can use that to create your own internal software catalog. The example that we've shown here is, for example, for a Jenkins service. So in this template, we will describe all the resources to be created, all the pods, the routes, how to handle the persistent storage. And then in the template, you can specify the parameters. That is what the user can influence with. I can decide how the template will be instantiated. So what do you think, Gilles? Are those mechanisms that you can use in your solution?
So, yes. Even if we don't use everything, okay, so we chose some some solutions, and I'll just show you how that now works. So, first thing is I took my case study application, okay, and I created, let's say, a behavior that's dependent of a variable. So here in our demo, I just set a variable that says if the service should show the hospitals or not. In fact, if it should hide the hospitals or not, okay, which is the opposite. As it's a Spring Boot application, I just inject here the value of hide hospitals, which can be a system property, but can also be an environment variable. So on the end, if you set the right environment variable, you'll have the right behavior. Okay, and then I changed my YAML file there, which was before a list of resources, into a template. So I created a template with two parameters, the famous hide hospitals value, okay, and an instance variable, okay. The instance variable I have to use to parameterize the name of the route, okay, because I can't just create two stuff with the same route name, so I had to do that, okay. For the rest, it's kind of similar. The only thing that changed here is that I added an env block here, where I defined the environment variable hide hospitals as the value that was entered into the template. So that's just as simple as that. So now I can go to my OpenShift environment here. Okay, log out. Yep, here we go. Log in. No, not that. Step 2. Okay, where I have my different environments, okay, what I'm going to do is I'm going to the test environment, and I'm going to deploy a healthcare provider service, but no. Okay, I might not going to do that.
Where is that template?
No, it's not there. Is it there? Okay, it's there. So I just changed my mind and wanted to deploy it in QA. So I'm going to deploy it in QA.
There's no need to test anyway. Directly
So
go to QA.
I'm going to say that I want the hospitals to be hidden, okay? And that my instance is QA, okay? So I can create, that's it. Here we can see that we'll have all our bullets there, okay, starting. If I go there, again, that 503, huh? Come back here. Okay, here you see we don't have hospitals. Okay, so basically, I could show you exactly the same stuff into another environment and change another variable. Okay, what's important here is that now I can parameterize my deployment for various environments and have them isolated. So, okay, as Jef just said, let's say a few minutes, some minutes ago, there are different ways to use OpenShift. Here I showed the console, okay, the OpenShift console, but let's say in reality, I don't go to deploy every application on every environment by just clicking in the console. So this is completely unrealistic. So we basically, in our production environment, we do the exact same stuff. So we use templates with parameter and environment variable, but we do that with scripting, basically, okay, via the CLI or the API, depending. So now I'm going to show you in our production environment, this is a typical pipeline. So this is a real pipeline we have in our continuous delivery tool, where every step, in fact, executes scripts that will trigger deployment and so on OpenShift. So here we use GoCD. This is the pipeline of the healthcare provider service, the real one, not the dummy one with just two providers. And so, in fact, how that works, on the left there, right here, okay, we create a template with a specific binary version just hard-coded in it, okay? Then we save that somewhere. When we need to deploy, let's say in some step here, maybe that one, okay, the QA environment, when we need to deploy, we are going to go fetch that template for the healthcare provider service, which here you have an excerpt of the parameters, okay? And resolve every parameter with an environment variable that's linked to the QA environment. So we have a list of 200 environment variables that really give all the parameters of all the services in that environment. And then using that, we generate the final list of resources where we are going to put into OpenShift. What's kind of nice is that list of resources, we can save them. Okay, we can put them somewhere, and if we want to reuse it later, we can just make maybe a rollback or just go back to another version. Okay, so it's really flexible for us to exactly deploy what version of what service in which environment. Okay, so this really allows you to coordinate the deployment of all your services and just go back in time too. So whenever this is done, we just put that in the G cloud. Okay. I see just put that. Okay, it's a bit more complicated than that because when you just saw me clicking, okay, instantiating a template, in fact, I created new resources. But if it was already there, I would have received errors, okay? So I would have to, using my scripts, to do a get and then replace and whatever. So there's a little bit of mechanic there to make that really work and be able to deploy what you want, when you want, depending on every situation. Okay, so this brings us to our, let's say, third question, which in fact is, okay, I have now done it for one service, but what if I have 2, 3, or 4, and how could they communicate? Because, as you said, okay, it's a cloud, there are lots of layers, we have virtual IPs, so where is my pod? How can I use it? What's his host name, what's his address, port, and so on? It might not be easy. So I might also have multiple pods, so I might need a list or something complicated. What do you think, Jef?
Yeah, so we already saw some of the concepts, but let's look at them in a bit more detail. So the first way that is offered is creating services. So the service, as Gilles already showed you in the first demo, is a virtual IP that will be fixed and constant for the complete lifetime of your service, which is completely different to the lifetime of the container that is delivering that service. So the container, yes, it is being recreated multiple times, and every time it will get a different IP address, but this service address will remain completely stable for the whole time. This IP address will also hide the fact if your service is delivered by 1 pod, 2 pods, or whatever pods. So that is already a way of simplifying your configuration. It works for all protocols because it's on the IP layer. And okay, how can you get to know this magical IP address? Well, the platform acts as a DNS, and your service name will resolve to this IP address. Again, it's not the only possibility. There's a lot of different ways of doing the same thing sometimes. Every service is also injected as environment variables. So you have the IP address and the port on which the service is exposed as an environment variable, and then you can use it directly in your application as well. The services are bound by the project scope. This is a very good idea because that way it simplifies your configuration. If you simply say, I have to reach out to the what was the name of your service again?
Healthcare provider.
The healthcare provider service. You just configure healthcare provider service, and in integration it will be the integration healthcare provider service. In production it will be the production healthcare environment service. So that is already one of the things that you don't have to create environment variables for yourself. But clearly, in these projects, you can't put everything in the same project. Sometimes you have to communicate outside of the project, and then you have the routes. And the routing layer that we saw in the diagram of the OpenShift solution is in fact just an automatic reverse proxy layer. So in the beginning it was only HTTP. Now in the newer versions you can do other stuff with that as well. But you simply expose it as you would do on a reverse proxy, but with a resource handled by OpenShift. And that way you can communicate between your projects and with the outside world. It also has a lot of support for HTTPS and all those kind of things, installing the certificates automatically. So
okay, small demo. So for this step, I typically can just go right to the OpenShift here. So basically what happened here is that I developed a new microservice, okay, which is typically the green paper encoding application, okay, that will need to have access to that list of healthcare providers. So I log to that one. That's it. Okay, so here we see that I have now two pods, okay? Only one is exposed by a route. So it's the green paper stuff, the reimbursement request. That's the general name of the certificates that are given by the doctors. And as it uses the other service, I had to modify its deployment config here. You can see that here, okay? And create an environment variable with the URI here, okay? And then I just bind it to the internal variables of OpenShift, which will, in fact, be resolved to the IP of the service, the same IP that we saw in the first demo, the same kind of IP. So I can show you how that works. Here, in the end, it's almost nothing there. Okay, so here, okay, here we have our list of healthcare providers that just directly comes from the other service. The thing is that that IP variable is just resolved on startup of the container. So if you end up by deleting a service, the IP just will change, and all the clients, all the other services that use that IP will just stop working. So you have to pay attention to that. But on the other hand, you have really almost no reason to never delete a service. It's almost never changed. So you just create it, and that's it. If I go back to, let's say, what we do in practice, or real-world application here. No, thank you. Okay, this is an excerpt. This is a dependency diagram from our production environment. So we have, okay, various services, different services, which are linked together. This is generated from the service registry, in fact, of OpenShift. So we do command line stuff to get that and generate the diagram. So we see that our services are kind of communicating a lot, okay? And we always use that virtual IP stuff, IP injection via environment variable. Most of all our pods have services, and only the UI stuff that are used by our business people have routes, and we use HTTPS routes everywhere. So now let's go back to our, let's say, last question, which is, okay, what about that 503?
Yeah, we were really lucky because during the demos, when we practiced it, most of the times it simply worked. And we never got a 503, but luckily today in real, we have seen that 503s are happening. So how can we make sure that you don't see that in production? Because then it's less fun. So one of the main goals of this platform as a service is to get zero downtime deployments. Your customers should not be aware that you are changing your containers. So what we are willing to do is doing a rolling deployment where we have the service completely up and running. Then we are going to add, let's say, the new version in another pod. And what we want to do is that the system is intelligent enough to say, okay, this new pod is also delivering that same service. And then if that is up and running, yeah, okay, scratch the link with the old pod and you can delete the old pod. For that to work, it's very important that the system is aware of when your pod is ready. And that was the main reason why it was sending these 503s up to now, because we never told the platform when our application was ready to serve. So what they provide are two kinds of probes. And the first is the readiness probe, which is a way of telling the platform, okay, my container is up and running, I'm ready to serve the traffic. So the netto effect is that if you don't say it is ready, the platform will simply not send any traffic to it. That's nice, that can help in this deployment, but then if it's up and running and something happens, another service dies, your database connection is lost, what are you going to do? Yeah, you can, with the readiness, remove the container from traffic, but that won't solve the solution. If you add, at the same time, a liveness probe, then you can tell to the platform, this container is simply dead. It won't be coming back, and your platform will simply restart your container, and maybe that will solve the solution. So you're in complete control. For each container, you decide whether you put a probe or not. You decide on what you put in. They support out-of-the-box HTTP GETs, where you can simply use the HTTP response code to pass on the status. You can also plug in a script that is inside your container. Then it will launch the script, and you can play with that with the exit code. And very important is this timing. So for each probe, you will say how frequently it is used and what are the timeouts that you can expect. Maybe for you, the service is not valid if it takes more than 5 seconds. Okay, then even if it will respond HTTP 200, but after 6 seconds, it is still considered to be dead. So you're in control to do that. So Gilles, can we have a try on doing this demo, and let's hope that now the 503s are
gone.
Are gone.
I think so. Okay. Log in again. Okay. Sorry. That's better. Okay, my Chrome doesn't seem to appreciate this. Hello. Okay. So we go now there. Okay. So I've used the same case study as the first demo step, so just a healthcare provider, really simple. But I've updated it so that now we have a rolling deployment. So I show you that. And I edit the YAML. So the deployment strategy is here put on deployment config, okay? And I put a little bit of parameters. So I asked him to check every second so that it works, which is kind of beefy, okay? Mm-hmm. With a very big timeout and maximum 0 unavailable pods. So we always try to have one working, which is a bit of the goal of all that. And then I've defined a probe. I just told OpenShift to do exactly the same thing as I did. Just go to the root and say that it works, okay, on port 8080, which is the internal port, okay. Now we can see how that works. So to be sure that you can really see that there is no impact, okay, I've made a small script here, okay, that will just pull the microservice and okay, here, and it shows, okay, the content of the answer and the code, which is a 200, okay. Mm-hmm. I'm not sure if you see that really good, but here you have a date, which is the date when the deployment started, which here is this morning, typically. Okay, so now I can show you, I'm going to redeploy, and typically the date should change, but the response status should be 200. Okay, so I go here, I go there, I'm going to do a deployment, that's it. Then we can go back here and see it in action. So basically it's the same stuff Jef described. You just create another pod. Now it's, let's say, blue, light blue, because it's not ready. So he's probing it. Okay, it's done. And that's it. If we look back, go to our script here, we'll see that there is nothing else than 200. Okay, and somewhere around here, the deployment was executed and the date changed. So that's just it, no impact. Let's say that basically it really works in production right now. So we can typically do a deployment just whenever you want.
No more weekend work.
That's it. Yes, not for that. Okay, so we'll typically go to the conclusions now. Mm-hmm. What can we say about our journey into the G Cloud? Okay, so it started a bit a year ago. We started to play with that a year ago. And let's say the first step were not always easy. We had problems, okay, typically, but we kind of work together and make it happen, make it work. So we are in production since April. The thing is that it just gets better and better. Features keep coming, okay? So there are new features like auto-scaling, like pipelines inside of OpenShift that we just receive. And so we can evolve and, let's say, adapt it to our architectures and requirements. Okay, so that's good. One of the things you might have noticed is that, okay, I presented a strategy, one way to use the different things, okay, but in fact you can really define yours, and because there are lots of possibilities, lots of tools, lots of ways to use those tools. So this doesn't come with a rigid process. You just can do what you want. So that's one stuff. And then for the flexibility, so yes, we are really happy because it's really flexible. We can really throw in a new service and just put it up to production really fastly without any manual intervention, just like that by creating new configuration. So it's really a good point for us and really a good point for our architecture to have that tool. Really goes, let's say, with it. And then on the end, last but not least, it works and doesn't crash. We never had any cascade crash. We never had any unavailability for, I don't know, some hours, whatever. No, we sometimes lost a node, but without impact. So we're kind of happy with that right now. So I let you conclude with the G-Cloud related stuff.
Yeah, so the main message that we wanted to give here, so it's not slideware. We showed you the play examples because we can't bring the complete G-Cloud onto a laptop, but it's really out there. So Gilles is there with over six environments with all their microservices on it, and they're scheduling 360 pods for that, but they're not the only ones. At this moment we are serving for 9 different tenants, so we're up to 900 containers on that. And okay, they're clearly not all new developments like Gilles is doing, so this platform is more than just a runtime for microservices. We are also using that to migrate existing software that we had in more traditional ways, and there this flexibility really plays, because the approach that you take for a microservices is not really the same that we are going to take if you are migrating an existing application. So the platform offers a lot of flexibility already, and like Gilles said, it's improving on different levels. In what we have shown you here, the version that is now in production, there are still things that remain a challenge for the user. So we haven't showed you monitoring, because we don't have a lot of integration there, how to get your application logs centralized, how to get metrics from that. But that is also the vendor who is in the community, because OpenShift is a community version. What we showed you there is the community version of OpenShift. In fact, they are adding features, but also the G-Cloud team is adding more services on top of that, is integrating this platform with a lot of existing services in this G-Cloud program. So more is definitely coming. And like Gilles already said, integration with CI, for example. So that still leaves us some 10 minutes for questions. If you have a question, we were asked to direct you to the mic that is located at the light post there. Feel free.
How tied in is your application code to the OpenShift platform now? How easy would it be to migrate to another platform as a service, for example?
So, except for some specific toolings that we use, like the graph generator, okay, the application themselves are not tied to OpenShift. They're just Docker image using environment variables. Sometimes, okay, files, but nothing specific. There is no OpenShift library or something like that. They're just regular, in our case, Java applications that are exposed like a process. That's just it.
Yeah. And also the configuration files that you saw, OpenShift is using internally the Kubernetes scheduler. The configuration files are not OpenShift specific. So if you take another Kubernetes-based solution or you install Kubernetes yourself, a lot of these deployment configs, the pods, the routes, and things like that, they will also just work. So it's really an open system, and that is one of the key reasons why we chose that to build our platform on it, just to make sure that we are not linking into one specific solution, but to remain flexible, to see how the solutions are evolving. Yeah. No more volunteers. Okay, so thank you very much for attending. If the question still arrives later on, Smals has a booth in the exhibition area. You can pause there. We will be there, or you simply give your question there and we can get in contact. Thank you.